So I'm Grégoire. I'm a research scientist at Meta Superintelligence Labs. I've been there for something like two years, a bit more. I started working on Llama 3 post-training, especially for tools, so a bit before agents. Then I created with some other folks from the team, like Thomas Yalom, a benchmark, Gaia, for web agents. And today, so I'm going to present some work we did around scaling environments for agents. So to develop agents, but also to evaluate them. I don't know how you do, folks. I'm fine with questions during the presentation, or it can be also afterwards, as you prefer. So why did we create ARI and Gaia 2 in the first place? So we started to work on agents a while ago, so perhaps like 1.5 years. And at that time, it was quite painful to work with agents. There was no good library for building agents. There was nothing to create environments. And so each time you wanted to work on agents, you needed to create a runtime and also create tools and also create content for the tools or try to connect actual tools. And so things quickly became very messy. Even creating tasks was a bit difficult. Ideally, you want to create verifiable tasks, but the more complex the environment, the more difficult it can be to find a good verification for your task. It was also very difficult to observe and debug agents. So as opposed to chat models, the outputs are much bigger. You have traces with tool calls, observations, faults possibly. And so again, all of this becomes one order of magnitude more complex than regular post-training. The other thing that was a blocker when we did our work was a lack of agentic evals. And in particular, so a few months ago, perhaps 9 months ago, agentic evals started to be a bit saturated. So you had very nice evals, like for example, Torbench, that test the ability of an agent to do some kind of multi-turn and calling tools to answer user requests. But again, these evals are starting to be a bit saturated now. You have also many tool-use evals that were perhaps not as holistic and complex as we wanted them to be. And we will also see that these evals were mostly focused around search and execution, which are good things, but perhaps not a good summary and do not have a good coverage of what agents can and should do. So we developed agent research environments that is meant to be not really an environment, but more like a platform. So we released it with one environment. I will discuss this environment a bit later, but really you should understand it as a platform to create new environments and diverse environments and complex ones. And so to do so, we propose some abstractions that we think are good and convenient. Perhaps there are better things, but well, at least this is something that you can use, guys. And so essentially, an ARI environment, it's a set of apps, and an app is like a coherent combination of tools. So an app can be an email, for example, with a read email tool, a write email tool, etc. So this is the core of an environment. Of course, you also have interfaces so that the user and an agent can connect to this environment and get notifications from this environment when something happens that you can choose to or not to process. And more importantly, when you run simulations in ARI, time is actually flowing. And so while the agent is working, actually the state of the world is constantly evolving, and not necessarily because the agent performs an action. Things happen outside of the agent responsibility. For example, if you ask your agent to, I don't know, summarize some emails in your inbox, it's possible that some emails will independently arrive in your inbox, or that you will get new messages from friends, and many other possible things. So yeah, an environment in ARI is a set of apps. Time is flowing when you run the simulation, and you can connect agents and users. And so based on this, there are already many things you can do. For example, something that we did very quickly is to re-implement some popular agentic benchmarks, typically Torbench, and we realized that those abstractions made it quite easy to re-implement those benchmarks. And so, for example, in Torbench, you can take the retail app, the retail tools, and create those as an app. And all the other abstractions in ARI are completely sufficient to quickly have a reproduction of Torbench. And the same goes for different other benchmarks. I see a question. No? Okay, we'll continue. So good abstractions, we think, for creating new environments. We also try to propose abstractions to create tasks. And so in IRE, we try to go beyond the concept of tasks towards what we call scenarios. And so as opposed to a task where you have, let's say, one prompt and the agent starts to work and stop, and then you verify what was done. In a scenario, we try to have richer behaviors and things happening. So for example, in a scenario, sure, you can schedule tasks. And so more precisely, the user will send some messages to the agents asking to do some things. But also you can schedule events to happen. So for example, to go back to my previous examples on emails, a task can be a user asking an agent to summarize some emails or to count the number of emails in the inbox. And you can also schedule events where emails, some of them are relevant, some of them are not, will arrive in the inbox. And so the agent will need to adapt to these new events. And so essentially, our scenarios are represented as DAGs, so directed acyclic graphs, with the events that correspond to user messages to the agent, events happening, events scheduled while the agent is working, and various other things. What is also important is, thanks to this graph structure, you can schedule events conditionally. So for example, I can decide that emails will start to flow as soon as the user message came to the agent, or as soon as the agent is finished processing the messages in the first place. And so this opens the door to many different scenarios with a lot of diversity and complexity. The same goes for verification. You can see verification as a part of this graph. And so, for example, you can decide that after the agent is done counting emails, you will schedule some verification to know how many emails did the agent count. And if the agent did well, you can continue the simulation. And if the agent did not, you can just stop it and spare some compute capacity. And so all of that, again, allows a great deal of flexibility, both in the tasks that you can create and also in the verification mechanism you want to have for your tasks. So, I discussed abstractions to create environments in IRE, abstractions to create scenarios in IRE. The third ingredient that we put in this platform are some observability tools. As I mentioned in the introduction, working with agents increase by one order of magnitude the quantity of information you need to process because you have tool calls, observations of the agent, things that happen in the environment while the agent was working, the thoughts of the agent if you have some. So much more things than just plain dialogues. And so to help folks working on that, we also developed a UI that allows you to visualize the scenarios you're developing. So this is the DAG that you can see in blue, purple, and green. So the colors correspond to where the events come from. In blue, you have events from the user. In purple, you have the events from the agent. And in green, you have the events from the environment that have been scheduled by the user. For example, some message from a friend will come while the agent is working. So you have tools to visualize these graphs in a UI. You can also run agents directly in the UI and observe what they are doing. observe tool calls and actions and observations that the agent gets. Also on the left, so sorry, it's not very zoomed in, but you can see apps. And so basically you can see what are the tools that the agent can use. And if you click on these apps, you can see also what is the content. So for example, in the mailbox, you will see what are the tools available for the agent, but also what are the emails. Click on an email, read the content, and this will really help you to create tasks and also understand what the agent did and debug if there is any issue. So this is all I wanted to say on IRE itself. And so, as I said, IRE comes with one environment. It's a mobile phone environment, so you should really think of it like that. You have apps like messaging, emails, file system, a calendar with synthetic content, but as realistic as possible, that allows the agent to play, execute actions, modify the state of the world, explore, experience, and so either train or do some evaluations. So in this environment, we also created a new benchmark for agents. Again, we did so because so we felt like that the previous version of Gaia, so Gaia 1, which is a benchmark focusing on web browsing, was a bit narrow because, again, it focused on web browsing, which is very limited compared to the spectrum of things agents can do. So this was the first thing, and also it was getting a bit saturated. And so we decided to create a more difficult benchmark, making it difficult not necessarily because the questions are longer, but rather more because the environment is complex, and now you can also perform actions instead of just reading stuff from the web. So you can modify the state of the world. And so basically, instead of thinking of harder prompts, we tried to think about richer and more difficult action space. So we created these 1,000 verifiable tasks in the environment I just described. I also say that IRE allows many different verification mechanisms. For Gaia 2, we chose to check the right actions. And so all the actions that will modify the state of the world. An example of right actions is sending an email. An example of read action that does not modify the state of the world, and so that we do not check, will be read emails. And so when the agent does something, so has a full trajectory and executes the tasks, we will just check this core set of actions that we think are necessary to consider the task completed. It's a design choice. We could revisit it later. You can also revisit it if you work on IRE, but this is what we did. We think that makes a lot of sense from, for example, a safety perspective. You really want the agent to not perform actions that are not desired. It's a way to have a less hack of your verification as well. I also say that beyond search, which was evaluated in Gaia or more recently in BrowseComp, and execution that is evaluated in Torbench and many other benchmarks, there are actually plenty of things that agents can do today. So for example, they can adapt while they are working. So for example, to go back to my example on counting email, if new emails arrive while the agent is working, it will need to revisit a bit its plan and adapt to fulfill the user prompt. Also, something that was a bit minor with chat models, but is becoming more important with agents, are ambiguities. Because when you discuss with a chat model and something is a bit ambiguous, very often the chat model will say something. And if you're not happy, you can just rephrase your question, ask again, etc. The thing with agents is they have an effect on the world. And so some ambiguities can have very bad consequences. And actually, for agents, you probably want to push a bit more for follow-up questions, clarifications questions, to make sure that you do not leave things ambiguous and so prone to critical mistakes. And so, for example, an example of task will be, I asked my agent to count the number of messages I got yesterday. A follow-up. If you have two messaging apps, you might want the agent to do a follow-up questions, which one of these apps. Or perhaps a more telling example could be send a message to someone, but it turns out that there are two people sharing the same name in the inbox. And so who should it be? And picking the wrong person or both person could have very bad consequences. So ambiguities are becoming, I think, important. Multi-agents, this is also a new thing that agents can become good at. If you imagine a world where our agents will interact between themselves, or for example, some famous websites become, or apps or APIs become accessible not directly via their tools, but via other agents with which my agent needs to interact with to get something done. Having an agent that is good at communicating to another agent to execute together on a given task will become important. So this is also something we added to the benchmark. And last but not least, I mentioned that in IRE, when you click run on a simulation, time is flowing. So we added tasks that require to have a good notion of time. For example, every 5 minutes, check my inbox and let me know when I received an email from Joe. So to be good at this, you need to understand what are 5 minutes, how does it flow, and make sure that the agent wakes up every 5 minutes to check the inbox and go back to the user when the desired message is received. So this is all we put in the benchmark. I'm going a bit quickly, but we can also discuss it during the questions phase. Of course, we evaluated the most recent models on this. And you can see that even the best models today do 40%, which is actually a lot. And it becomes not that trivial to create challenging questions for the best models today. So beyond just pure scores, which are interesting signal, but perhaps not the whole story, we try to analyze a bit more what is happening with different agents. And so when you consider these new tasks, multi-agent or time, for example, you start to observe new things beyond just pure performance. Typically, something we did for time was comparing the scores of the model when the scenarios execute in real time versus the score of the model they would have gotten if the generation time was considered instantaneous. So basically, you simulate the fact that generation is free, it's 1 second. And so you see how well do the agents do on these time questions. And interestingly, you start to see interesting things. For example, a model like GPT-5, which gets 0 on time because it's extremely slow. And so it always does a good reaction, but too late. And so the scenario is a failure. For example, it will miss the 5 minute mark. It will react after, let's say, 6 minutes because it was thinking and was too slow. When you consider the generation as instantaneous, you see that actually on time, GPT-5 is not that bad. It does 34%. Same for other popular models. And so, for example, with the time capability, you have some inverse scaling law, which is the bigger model will perform poorly, worse and worse on time tasks because they are just slower. And in real life, sometimes you really need to have fast answers. And so I think this is something that models can deal with via different techniques. But I think this redefines a bit, and this is where this set of tasks are interesting, perhaps redefines a bit what it means to serve a model. Is it just having the best replies, or is it also to have fast replies? And how do you make sure as an API provider that you can provide a response in due time? So this is a very brief overview of the paper. So I did not put the link of the paper because I assume that you are already aware about that. I put, however, two more links complementary to the paper that is an archive, which is first a link to our Hugging Face space when you have a demo of the IRE. And so in the UI, you can interact with Gaia 2 environments, you can load the questions and inspect the questions. There is also a Gaia 2 leaderboard. So the demo is free. We provide a few agents that you can try. So you can really just put your tasks. There is a chat box and see how the agent does on the environment. And of course, all of this, so the environment, including the abstractions for environment creation, tasks, Gaia 2, and part of the UI are available in the public repo on GitHub. This is all I wanted to say for today, so perhaps we can move on to questions.
Cool. Yeah. Thanks, Greg. That was great. Definitely feel like there's a lack of like really strong benchmarks for agents, and so yeah, it's very exciting. So we have some questions. Manav is asking, you mentioned earlier that time flows independently from agent actions. Does it mean the action space becomes much more sparse? Does it increase any computation requirements?
What does it mean to, I mean, it depends on the modeling you choose, I guess, to deal with time. In some modeling, you can have the agent sleeping when it's doing nothing. So I don't think it will increase computation a lot, and the agent could be waken up when something happens in the environment. You can also choose to have an agent that is always on. In that case, it might be more costly. But I think it depends on how you do your modeling.
Got it. Yeah. Thanks.
Cool. Okay. Another question we have from Katir. So he's asking, is the platform dedicated to evaluation, supervision, prompt optimization, red teaming, compliance? Maybe like what are the different things or the high level goals the platform helps solve?
I think all of this, it's very flexible actually. So you can create tasks for evaluation. You can create also, let's say, malicious tasks for red teaming. I don't think I think all of these things are possible.
Cool. Okay. Any other questions? We have some time, so feel free to ask. Katir asks, how can I get training on this tool? Or how
Uh,
can, yeah, sorry, go ahead.
do you mean documentation?
Yeah, I think that would make sense.
So, okay, so in the Hugging Face space, we provide some, so there are direct links to the documentation for the tools. And so you can see how to become familiar with the abstractions and also the UI, the UI.
I actually have a question regarding I know this is like quite new and proprietary, but what are some of the like are there any opportunities to kind of bring this to industry and what are some of the hurdles there, do you think?
You mean the platform itself?
Yeah, like the platform itself or at least the concepts
Mhm.
you know.
I don't think there is any hurdle because we release under a permissive license. So if it's useful for you, you can use it.
Okay.
Cool. Well, I think that's it for us. And
Cool.
thanks so much, Greg.
Thank
Yeah.
you, guys.
Thank you.
Yeah. All right. Bye.
Bye.